So this video is to answer Mina's question about what does it mean when I say that all numbers want to be rectangles, or that we could actually see numbers as rectangles. When we're using manipulatives in base 10, we basically start out with these little blocks that you can not only see, but you can also touch and play with. So math becomes not just an abstract idea, but physically something that you can get your hands on. And it becomes fun because you play with it. You're not just memorizing, theories or equations or formulas. So we start out with a 1. You could take two ones to make a 2, or you know what? We have a rectangle for that. There's a 2. This is a 3. This is a 4. Then we've got 5, 6, 7, 8, and 9. So these are all of the rectangles that make up our basic units. Now, when we get to the 10, we have 10. So these are ones. And we have a 10, which is basically 10 by 1, or 1 times 10. And so we have, tens. And then we take a 10 by 10. That would be the same thing as a 100. So those are our basic building blocks for the fundamentals. Now, when we get into doing multiplication, all we're really doing there is building rectangles. So we could say, 2 by 3. All that really means is that we've got, that's a 2 by 4, sorry. If we say we have 2 4s, all we're doing is building a rectangle, right? 2 times 4, and we could count those units, and we know that that's 8. Now, most of us have memorized the multiplication table, 12 times 12, or up to that, and we really don't have an idea about what it means about the rectangles, though. So when we go to larger numbers, say like 12 by 13, that's where we get confused, and the breakdown starts. For some people, the breakdown starts before that because you can't remember what you memorized. So if we're building rectangles, we could very easily take our 10, 11, 12 by 13. All we're doing is building a 12 by 13 rectangle. We've got our 100s, we've got our 10s, and then we have this hole in our rectangle right there. So what is that hole? It's just a bunch of 1s. So we've represented this not like this. We can still see it like that, but this, we don't really have the physical understanding or the concrete understanding. This is still abstract for most people. So here we could look at this and go, oh, you know what? This answer is, what is 12 times 13? We know it's 100. How many 10s do we have? We can count them. There's 5, and so that's 50. And then how many units or how many ones? There's 6. So the answer is 156. So all we did is build a rectangle. Now we can do the same thing with fractions. It's just as easy with fractions. So if we wanted to build, for example, or multiply 3/4, so we could take, there's 3/4 times 2/5, and we wanted to really understand this, what we would do is just build a rectangle. So here's a rectangle of 1, 2, 3, 4. Okay, this is our foundation, times 1, 2, 3, 4, 5. And then we could take our 3/4 times the 2/5. Now, this top part, we've got a bottom rectangle, but our top part also wants to be a rectangle, right? So all we have to do is build the rectangle. And once we've built the rectangle, we could count these. There's 6 of them, and that's over 20. So we know that 3/4 times 2/5, okay, this is 6 over 20. Now we still have to reduce that, but all we've done is built a rectangle. Now, how does this relate to algebra? Well, if we go back to the idea of squaring numbers, and all numbers want to be rectangles, or we make rectangles out of the numbers. Let's take our 12 by 13 example. So basically what this is, we had our 12 times our 13, and then we filled in those missing 6s over here. This is where we have the algebraic equation if we're solving for x, right? And by the way, my 3-year-old is learning how to solve for x. So I'm going to jump off to another example here just quickly, but if we say that we've got a 5 and a 2 wants to be a 5, what's missing? X is what's missing. So all we have to do is count 1, 2, 3, and we know that x is equal to 3 in that case. And that's how we're starting to give this very basic, simple understanding for her in solving for x with counting up to 10. And so we're doing that, and it's a fun game. Now, in this case, from the algebra perspective, we've got this x here, which is, x is our 10. So this is basically x squared. Okay, so we built a rectangle, 10 by 10. And this is how many x's? We've got 5. And then how many units do we have? There's 6. Okay, that's a little sloppy 6, but here's our 6. So basically this is representing, when we had that square, this represents x squared plus 5x plus 6. And then we've squared the numbers. So I hope that answers your question.